Alright. I need the full 10 minutes for Gradle to wake up. Alright, alright. The lag is real. Day 20. Okie dokie. What's your deal? Oh. Oh, crap. Oh shit, dude. It's Scott Griffith. I'm coding, bro. I'm doing Advent of Code. You know what an Advent calendar is? It's like where you pop out chocolate every day till Christmas, but this is that with coding. And we got Dos Equis. It's a good night. We'll see what kind of autistic problem they give us tonight. It's probably going to be an integer. It usually is. Oh, spotted cow. Everybody talks about spotted cow from like Wisconsin or some shit, right? Everybody gasses that beer up. I've never tried it. Rainier? I don't even know what the hell that is either. Rainier? Is it Rainier or Rainier? 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 I'll check it out. Oh yeah, that looks good. Wood drink. And yeah. Okay. Alright, bro, I'll hit you up. I'll hit you up next time I try spotted cow. Oh. Let's actually see what last year was. Real quick. Yep, don't remember that one. Two minutes. One minute. The historians are quite pixelated again. This time a massive black building looms over you. You're right outside the CPU. While the historians get to work, a nearby program sees that you're idle and challenges you to a race. Apparently you've arrived just in time for the frequently held Race Condition Festival. The race takes place on a particularly long twisting code path. Programs compete to see who can finish the fewest picoseconds. That's like a what? Trillionth of a second or something? The winner even gets their very own mutex. They hand you a map of the racetrack, your puzzle input. This is our sample input. Okay, this is the racetrack. Okay, that's start and end, I guess. This is gonna be another Dijkstra's. The map consists of a track, including the start and the end positions, both of which also count as track, and then these are walls. When a program runs through the racetrack, it starts at the start position, and then it is allowed to move up, down, left, right. Each such move takes 1 picosecond. The goal is to reach the end position as quickly as possible. In this example racetrack, the fastest time is 84 picoseconds. Yeah, because there's only a single path from start to end. There's only a single path. Oh, it's like a maze. There's only a single path from start to end, and the programs all go the same speed. The races used to be pretty boring. Oh, to make things interesting, they introduced a new rule to the races. Programs are allowed to cheat. The rules for cheating are very strict. Exactly once during a race, a program may disable collision for up to 2 picoseconds. This allows the program to pass through walls as if they were a regular track. At the end of the cheat, the program must be back on normal track again, otherwise it will receive segmentation fault, get disqualified. So a program could complete this course in 72 picoseconds, saving 12 picoseconds by cheating for the 2 moves marked 1 and 2. Shit, boy. Or a program could complete the course in 64 picoseconds, saving 20 picoseconds by cheating here. Oh my god. This cheat saves 38 picoseconds, and this one saves 38, this one saves 64. Each cheat has a distinct start position, the position where the cheat is activated just before the first move that is allowed to go through walls, and the end position. Start position. Oh, okay. What? Oh, okay, I see. Let me look at this one. You'll need a list of the best cheats. How many cheats would save you at least 100 picoseconds? Oh man. So there's one path through there. There's one path through there. And we're allowed to go through 2 walls, is that it? Okay, so I'm gonna do a DFS since there's only one actual path. Yes, since there's only, well, yeah, I think a DFS would work. And each cheat has a distinct start position, this position where the cheat is activated just before the first move that is allowed to go through the walls, and the end position. So 1, 2. Okay, so you're allowed to go through one wall then? Yeah, I think. Okay. So I think I can just do a DFS. We're going to have a grid. And then the number of rows and number of columns. And then, so we got our grid. Actually, I need to, no, it's just ready to go. Okay, so we got that grid. Throws, exception, and then we're gonna find how many paths save at least 100 seconds. So, or how many cheats. How many cheats save at least 100 seconds? And in here we're going to want a position. We're gonna need shit. Wait. Will a DFS work? Because there's one path. Well, it doesn't even need to be a, yeah, DFS. Man, this is weird. Well, I think what I could do instead is I could actually just iterate through the grid, get rid of one of the walls, do a DFS, and get, well, don't do a DFS, do a Dijkstra's. I don't know if that's the best solution, but I could iterate through, because I'm only going to be able to go through one wall, right? Yeah. Wait. Where the cheat is activated. Like here. Well. Yeah. Well, you're allowed to cheat for 2 picoseconds. I don't know if that means I can go through 2 walls or 1 wall. We'll just assume one wall for now. So I could just go through each. And then I could just be like, and then if this is actually just gonna be a DFS. Is it gonna be a DFS? No, it's gonna be a Dijkstra's. Yeah, I guess I'm gonna do Dijkstra's. Fuck. Wait, can't you use... shortest path? You can use DFS for shortest path here. I think it'd be fine. Yeah. I'll shoot DFS. If DFS... 0, is at least 100, then well, shit. Yeah, sum plus equals 1, or sum plus plus. Yeah. And up here, we actually will have a count. I'll just say distance. That's going to start as 0. And if we're at the end, if grid ij equals the end, then return count. And then we're going to go through all the neighbors, DFS those neighbors. And we're going to go up, down, left, right. Up, down, left, right. Turn distance. For direction 0. There's 4 directions. If J is not equal to a wall, let's go that way. And we actually want to return the min, so equals I plus did j plus djd distance plus 1, and then at the end just return that minimum distance. Will that not work? I feel like it does. question is, let's see here. Yeah, I guess let's try it. Oh, I think I need to have a visited. Set. Let's do node 2. Ah, shit. Actually, let's just do it up there at the top with another base case. It'll be cleaner that way. If I is out of range, or J is out of range, or visited dot contains J, we're going to return int dot max value. Then I need to pass a hash set here. Okay, I feel like that'll work. No. We forgot to add it to visited. Fuck. Visited.add. Let's see. Why would that? Oh, it worked like that? Okay, so it's just too damn big. I might have to do Dijkstra's then. Shit. Yeah, it's just too freaking big to do it like that, so we will do shortest path then. Shortest path. Shortest path. It's gonna be the distance. Oh wait, actually what we're interested in is like how many seconds you save. So first we actually want to just find the actual shortest path. So to do this we're going to want a node start and yeah, that's all I need. We're gonna need our start node. Just trash this, see you later. And we're gonna need a distance map. It's gonna map a node to its distance. It's gonna be an integer. And we're going to need a queue that's going to map a node and a distance, or it's not mapping anything, it's just going to contain entries that contain a node and a distance, and that's going to be a priority queue. And we're going to compare P1 and P2. We're going to compare their P1, we're going to compare the distance, P1.getKey. What, bitch? P1.getKey. Is it P1 key? Yeah, P1 key dot compare to P2.key. Oh, value. Shit. Okay, and then we're gonna add start to the queue. Start our new pair with start and the dang old 0 for the distance, and while not queue is empty, we're gonna pop from that queue. It's actually an entry pair. Equals queue.poll node 2 u equals entry.key and dist entry.val, and we got walls are all around the outside, so how did I do this before? Yeah, we should check if we have reached the goal. And dot x. Okay. I'll just say IJ right here. If it's not a wall, then if distance dot get v, the default's the max value, is less than what? Is less than what? You... I was less than dist plus 1. Then q.add v dist plus 1 and distance dot put v with dist plus 1. Yeah. And then at the... that should get us there. Shit. And now I just need to find the... titties. Alright. And now let's find those first. So... find the start. Let's actually call that equals find. Come on, motherfucker. Find the E. And let's make those nodes. Oh shit. Yeah. And then if shortest path start to end is actually we need to find the actual shortest path, so shortest path distance shortest path start to end, then here shortest path distance minus that is greater than or equal to 100. What? Then, yeah, plus sum. Well, that's not right. Oh wait, we didn't reset. See if our shortest path is working. So shortest path distance. And the shortest path through this guy should be 84. Well, that's not right. Okay, something's wrong with this. Up, down, left, right, up, down, left, right. Maybe print out the grid. Looks good. Definitely something to do with this Dijkstra's. We've got our start and our goal. 0, 1. Oh wait, I got my condition flipped. Such a freaking idiot. That should show me 84 for the shortest path. It does, but then we just get an index out of bounds on 71. Oh, okay. So I need to check that that's not out of bounds. How would we be? Okay, guess we're deleting things on the edge too. Okay, pretty sure that'll give me the right answer for the real thing. Unless we overflow or some shit. Fuck. Crap. But our shortest path works. Oh, we're actually still executing. Okay. That's... Let's see, like, how far we're getting. Shoot. What's the size of our freaking thing? $141. I think it'll finish. It won't take that long. I'll just let it run. I'll try to make it faster later. It'll finish. Let's just print out I up here. Oh, mother. Okay. Just gotta let that get to 141. It's pretty slow. And I think I might I'm probably supposed to get rid of 2 walls at a time. I don't know if that's gonna be right. Yay! Alright. Apparently the 2 picosecond cheating rule was deprecated several milliseconds ago. The latest version of the cheating rule permits a single cheat that instead lasts at most 20 picoseconds. Oh my god. Now, in addition to all the cheats that were possible in just 2 picoseconds, many more cheats are possible. Son of a gun. 6-second picosecond. Yeah, my current strategy will not work for this. So now I can cheat up to 20 picoseconds. Damn. So I wonder if I could just modify my Dijkstra's somehow. Damn. Dang. So I could do Dijkstra's and then okay, actually I have an idea. No. No, I do have kind of an idea. I could do midway through my Dijkstra's. Okay, so I could do Dijkstra's, and then when I get here, when I get to my note, after I check that's the goal, what I could do is I could shoot. Try to find the shortest path from right here, ignoring walls. How in the heck? How would I be able to? How does A-star work? I think this like uses a Q too, right? Or not? It's a bit different. Yeah, it's kind of this. So I could get here and then let's say break off and do another search and ignore up to 20 walls, or is it up to 20 walls? It's my current way of doing things. There's really no freaking way I'm gonna be able to. Ugh. See how slow I am. Oh yeah, it can't be that hard then. So I could like do Dijkstra's. And then I want to say once I grab this node, don't want to just see if we can get there in 20. Actually, I kind of could do that. Okay, actually, so do Dijkstra's, and then I would like break off right here. I would just use like Manhattan distance. Well, that won't really tell me. You got like the twists and turns. I feel like you just want to take a straight ass turn towards the end. Not really though, huh? Just right here, it's not just dead ass turn. Well, this is the best path actually. I mean, you could zigzag, it'd be the same. Shit. Damn. Well, you could start cheating here. Dang, this one's crazy actually. I don't know. So, yeah, I'm not gonna get help till midnight. I'm just gonna sit here. I could do Dijkstra's, and then once I pop a node, I could... Shit. Yeah, because it wouldn't just be getting to the end. I could cheat a little bit in the beginning of the race. But really the farthest you could get, actually the farthest you could get would be 20 cells Manhattan distance. So... And would you always necessarily want to cheat towards? I don't think so. Maybe. Would you always want to, when you cheat, would you always just want to move towards the end? Would you ever find benefit? Yeah, I think there would be cases where you'd find benefit in moving away from the end. Huh. So there are cases where you could move away from the end, but it would still benefit you. What if I try to just... Yeah, trying to remove all combinations of 20 walls, 20 adjacent walls is insane. Actually, you don't want to do that. Well, could I... Could I somehow add to my Dijkstra's to keep track of how many walls we've been through already? What I keep on wanting to say is you could just Dijkstra's and then break off, do another Dijkstra's to get to the end, and then check. That would be so slow. Check if you're more than, if you're within that 20 Manhattan distance. But you could also cheat in the beginning of the race or in the middle of the race. Dang. Oh, crap. Oh, my lord. Actually, see, you don't want to just move towards the damn goal every time. I was going to say this time, at any node that I get to, let's just veer off straight towards the end, and then just start a Dijkstra's there. But sometimes you could benefit from moving away from the goal, so that wouldn't work. You could kind of change it to go in 1, 2, 3, 4, 5, 6, all 8 directions, orthogonal directions. So I'm doing Dijkstra's. I pop off a node for all 8 directions. We'll just veer off, and then we'll begin Dijkstra's from there again. We'll veer off. Shit. Sometimes. Well, let's see. Dang, this one's... I have no idea how to solve this one. I have not a clue. Oh my goodness. Help me! Help me! I need a beer. Out in the West Texas town of El Paso. Come on, motherfucker. Dashing down the drink he was sharing with wicked Felina, the girl that I love. Okay. Brainstorm. So let's say I get like way over here. And damn, dude. God damn it. This problem, dude. It can be that crazy, because, like, you know, the times are pretty short today. So I don't think it's, like, that crazy. I'm just thinking about it wrong. Hmm. We can cheat up to 20, or at most 20 picoseconds. Oh, wait a minute. I kind of have an idea here. I can increase the dimensions of my nodes, and I could add to the queue a node where I start cheating and a node where I am not cheating. And I'd also need like a little, maybe a Boolean. Oh, actually I could add one with 0. I could add another count. So if I use a node 3 and then use the third value in my node to represent the count of how many times that we've cheated so far. And whenever you pop a node that is a cheat node, you can either stop cheating or continue cheating. If you stop cheating, then yeah, it also needs some kind of flag. So that would be, my nodes would need position, so X and a Y, and then I would need to keep track. I would need to keep track of how many walls I've been through. And then I would need like a Boolean to tell me that we're done cheating or whatever. Or I could just set the thing to 20. Yeah, so whenever I pull a cheating node, I have two options there. I can keep cheating, Or I can stop cheating and I would just set the count to 20. I think that would work. That could work. And then I'd want to do all Dijkstra's solutions. Or I'd be interested in... Let's see. Yeah, and I could just add the distances to a set, so I think that would work. Yeah, I think that would work. So let's go over that plan again. I could just increase the dimension of my node just by 1. So then I would have a cheat count, basically. And whenever I poll a node, if it has a value other than 0, I have 2 options. Well, let's say I poll a node that has a value of 0 for cheating. When I add to the queue, I can add... Oh, shit. Yeah, I can add any neighbor, even if it's a wall, and then just plus 1 to that cheat value. And if it's not a wall, don't plus 1 to the cheat value. Okay. And then instead of returning the distance, just keep track of those. Keep track of those in a list, actually. And then when I poll a node that has a non-zero cheat value that's less than 20, I have 2 options. I can keep cheating. Oh, and I kind of glazed over. Okay. Okay. So instead of returning here, let's turn this. So instead of returning there, and this would work for part 2 as well, the cheat count would just be different. So I am going to change this to return a list of integer. That's going to be all the different distances that we came up with. Path lengths. So that's going to be all the different path lengths that we have, and instead of returning a distance, we'll just say path lengths dot add distance, or dist. Okay. I think this might work out. I'm going to have to go over my plan again before I forget what I was just thinking about. So return path lengths. I can actually just return path lengths dot stream dot filter is less than or wait. Just return it. We'll just return that damn path lengths. for now. Okay. So instead of using node 2, we're going to use a node 3. We're going to use node 3s instead. Yeah, and this is going to be node 3s, and this is going to be, this is going to have to be a node 3 now. This is going to be a node 3, node 3, and yeah, if we're at the goal, good. As for going through, the distances, well, yeah, okay. No, we'll just let it keep going. Okay. So that's going to be the new direction. First we want to see out of range. Let's change this. Now, so if we're not off frame, and let's just start with that. So if we're not off frame, we have maybe a couple of options. We can cheat if u dot z is less than 20, maybe. If it's less than 20, we can cheat. We can cheat. So we can say so if we're now out of frame, okay. If the cheat value is less than 20, let's add a node that starts cheating in there. So we'll say node 3 v equals new node 3 I j I j if it's less than 20 but greater than 1, let's say that u dot z is greater than 0 or it's less than 20, I'll say and. If it's greater than 0 and it's less than 20, let's do a cheat. So this will be u dot z plus 1. Queue that up. Well, actually, we'll say if we'll say if dist plus 1 is less than distance dot get or default u shit. What was it? What am I supposed to do there? Oh yeah, v. Then q dot add new pair v dist plus 1, and then distance dot put v dist plus 1. So that's cheating. We also have the option to I could say v equals new node 3. Now this might less than 20. Well, like, what if this one's 19? If it's less than 20. This might be fine. I, J, and then just set this to 20. We're gonna stop cheating right here. Yeah. And then kind of the same shit right here. Okay. Thing is, I could get a duplicate node right there. So let's try to avoid that. There's a better way to do this. I'm just trying to get through this, man. So that's stop cheating. Else if, yeah, else if u dot z equals 0. So this is a node that has not cheated before, and it also has two options. It could begin cheating, or it could just continue not cheating. So we're just going to take all this doo-doo. So we're going to have node V. Probably don't need that for this one. So I can either begin cheating by adding 1 there, right? Okay, yeah, and I need to actually, for the not cheating one, for the stop cheating one, shit. For the stop cheating one, I have to make sure that I'm not in a wall. I'll make sure that I do that in a second. Okay, but if Z is the cheat count is 0, I can begin cheating by adding 1 to this, or I can just continue not cheating. I, J, u.z. Yeah. And the important thing here is that IJ. So for the ones that we stop cheating, if we're going to stop cheating here, I need to make sure that I'm not stopping on a wall. And then for this one, it doesn't matter if I'm on a wall, but right here, when I'm not cheating, I need to make sure that I'm not in a wall. Okay. I feel like that might do something. So let's see here. I still need to actually know the shortest path. So that will just be the first one in there. So that'll be path.get 0. I'll actually do this. List shortest path distances. I'll just say path distances. And the these need to be node 3s now. Oh crap. Yeah, that's fine. This will be node 3. And what? War? Oh, okay. Okay, I feel like that'll do something. So I got those path distances. Let's make sure that it still like works normally. So let's print out path distance dot get 0. Oh, the shortest path. Shit. Well, why don't I make that an argument? So cheat limit, and then replace these 20s with cheat limit. And then pass that in right here with a 0. And when I print that out, I should get 84 for the sample. Frick. The size is 0. Oh, what the hell? Yeah, that'll fucking screw it up. Okay, 84. So this should get me back a big old list of distances. So then I should just return the path distances dot stream dot filter so that's the path distances. original distance is just going to be path distances. Why don't I do this? Dot get 0, and then set this cheat limit to 20. Path distances, filter distance to original dist minus d is greater than or equal to 100. Is it 100 still? Yeah. Dot count, and that returns a long, so there actually might be a buttload. We'll just see if that even runs. $15 definitely does not sound right. So let's see it with the sample here. So I love how they didn't do it for me. So for the sample, I should get, there are 32 cheats. Plus 31, plus 29, plus 39, plus 25, plus 23, plus 20, plus 19, plus 12, plus 14, plus 12, plus 22, plus 4, plus 3. $32 plus. So 285 is what I should get for the sample. I get 0. So but this part works. When I set this to 0, it works, right? What are we printing out? This should show me 84. Yes, okay, so that works. I'm just need to fix my cheating logic here. So if the cheat is greater than 0 and less than the cheat limit, then I can continue to cheat or I can stop cheating. I can continue to cheat or I can stop cheating. And shit. Maybe I don't need this part. Maybe you're allowed to be in a wall right there. No, that didn't really make a difference. So, if the cheat count is greater than 0, less than the limit, then the next node I can add to the cheat count, and yeah, who cares if it's a wall? Add that sucker to the queue and map its new distance. I could also stop cheating right here. So for that, I just set it to the cheat limit. And if it's not a wall, and that's not even gonna. So this part works apparently. Oh crap. Well, that's if it's 0. Yeah, it'll get ignored. Interesting. How many? So it have 15 in there. So we can either cheat or not cheat. So greater than or equal. Why don't I just do it all right here? Couldn't I just do that? I feel like I could. See if I still get 84 right there. No. Oh. No. Where's that? Oh, now we're not getting anything. Okay, so I need that part, I guess. We can start cheating or just go as normal. I think it's so something about the cheating limit. What was it? The sample should be 285. What about for the first example? Oh wait, at least 100. Well, fuck. So at least 50. How many are there that it save at least 50 in the sample? $19.32. Okay, so we're under counting. We're undercounting. We can start cheating. Or continue cheating is what that is. Or we can stop cheating. And when you I think when you stop cheating, it's okay that you're in a wall, right? Maybe. It didn't matter. But I think so. Oh, you know what? Well, why don't I just do this? Not Q dot, well, that wouldn't. Oh. So maybe I need that part. Maybe. Didn't matter. Because there should be 32. There should be 32 that are at least 50. Let's save you at least. Yeah. Well, yeah. There should be more, actually. Yeah, there should be a bunch. Yeah, it actually should be quite a few. I feel like I'm on the right track, though. Oh! Oh, no. Oh, you know what I'm not doing? I'm not handling the condition where the cheat limit has been met. And for this, it should be super simple. First, you want to see that you're not a wall. Yeah, that was probably it. No? Huh. Huh. So you pop off a node here, you go through each direction, and I'm just getting my new row and column here. And if we're not at a frame, let's say we have a node that is currently cheating. The next node would be, you have two options there. You could do a next node that's still cheating. You can continue cheating, or you can stop cheating. And to stop cheating, I'm just setting the cheat limit setting the cheat count to the cheat limit. And yeah, that seems right to me. If the cheat count is 0, we can either cheat or continue not cheating. You want to do both, I think, right? Yeah. Yeah. And then if you're at the cheat limit, it's pretty much just continue on as normal. If you're not at a wall. I don't see why this wouldn't work. I don't see why this wouldn't work. I'm undercounting. Let's actually just see how many we have total. And this should be like 2. Actually, I don't know. I don't know how many's in there actually. 21. Yeah, we're undercounting somehow. Undercounting. So if we're in the middle of cheating, we can continue cheating. Or we can stop cheating. And if the cheat count is 0, we can start cheating or continue not cheating. And if the cheat limit has been reached, then we can continue moving the distance, but we can't cheat anymore. I feel like this should work. Huh. I think the problem now is my direction, maybe. Do I need to put direction in there? I don't think so. So I'm undercounting, so maybe it's because that I need to put direction in the nodes also. Because I could have like a node Damn, boy. I think it's time to get help now. Time to get help. Let's look at Jonathan Paulson. So yeah, Dijkstra's. Find cheat. So cheat start, cheat end, cheat time. The cheat start, the cheat end. What the hell would cheat end be? So that gives me some hints. So the distance, the cheat start. Yeah, that's why I'm undercounting. See, cheat start. Wouldn't I just need cheat start in there? Cheat start, cheat end. And cheat count. Yeah, I guess I would need that. Do I need cheat end in there? I think cheat end would be the same as just the position, right? Not necessarily. Yeah, not necessarily. Yeah, you do need the cheat start, cheat end, the cheat count. Oh man. So I need distance in my queue. I need cheat start. Cheat start, cheat end, row column. Is that what he's doing? Yeah. Let's try that. And that would be my node, and I'm just going to keep the distance separate. So I'll just make another class here. Node. It'll have int start. I got this. I was undercounting because I wasn't putting all the information I needed in my queue entries. So actually the start will just be a node 2. Start. Node 2 end. We need the start and the end and then the count. They're also going to have a position. And it's going to have a start. All of that crap. Start to end. Count I. Okay, I'm gonna want an equals in here. Other dot start dot equals start and other dot end dot equals end and other dot count equals count and other dot I equals I and other dot j equals j and a hash code. Return start dot hash code. I don't really, let's see, end dot hash code. We'll just throw some primes in there in a second. Plus count plus I plus j. Okay. So now we're just gonna have this take a node. And this needs to be a node now. Alright, this is going to be a mess. Okay. So we get our entry node distance. And if u dot, I can actually just say oh, I should make this X and Y. You butthole. Alright, we're going with I and J. Fuck. No. I want it to be X and Y, damn it. Let me just comment out these. These mama jammas. Still got one. Tits. All right. So if u dot x equals goal dot x and u dot y equals go dot y, that's a path. Okay, go through all the distances, get the new position. If we're not off frame, u dot count this time. If u dot count, so if we're in the middle of cheating, then the new node is going to be cheat start, cheat end, count ij. The cheat start, okay. Yeah, this will just be u dot start. U dot end. I gotta update end before I get here too. Start end count, u dot count plus 1. We're gonna keep cheating right here. What are we missing? Oh, the position. U dot x. Oh no. I and j. Yeah. And then similar here. But in this case, we're going to stop cheating. So, I think I can still just set the count to the limit and it would be okay. If it has never counted or never cheated, then we can start to cheat. So the start would be a new node ij. That'd be the start. The cheat end would be the same. Oh wait, this would just be a node 2. The end would be the same. And then you need ij. No, count would be. Would the count be 1? Yeah. And then ij. What? Node 2. So that's if we decided to start cheating. We could also just continue not cheating, and that would look like the same, except this would be null. Null. So we haven't cheated yet. Count 0 still. ij. And if we're not, a wall. Okay. And if we're at the cheat limit, if u.count equals the cheat limit, then it's going to be basically like this, except it's going to adopt u.start and u.end, u.count, ij. Maybe that worked. I'm missing something. Oh yeah, I need to update. Let's see. I need to update. So if we're going to keep cheating, then the end would actually be the next position. And if we're going to stop cheating, then the stop would be the last position. And if we weren't cheating before, yeah, the start would be here, the end would be here. Or would the start be the previous one? I think the start would be the previous one. U.start. What if it's null? Oh, I'm gonna get null pointer exceptions down here. God damn it. Well, I'm actually not using like contains or anything anywhere. It might be fine. I don't know, let's see what happens. I got a C source path, start and yeah. Start and 0. What am I missing? Oh. I don't know. Let's do 100. Let's just send it, see what happens. Damn it, I knew that was gonna happen. Oh, because I'm using a hash map, yeah. So I need to equals oh, in the hash code? Yeah. All right. Wait, what? War? Oh wait. Other dot start equals null. Thought that would handle that. What are you talking about? Oh, mine could be null too. Oh shit. I don't know. Damn it, it's too low. I'm still undercounting. Oh, we're actually still executing. How slow is it going? I don't know. How slow is it going? Is my queue maybe? Let's try with the sample. 237. Let's do greater than or equal to, well, let's do, what was it? At least 50. I think I was supposed to get 285. No. What is that, 237? That's the whole path length. Okay, still undercounting. Okay, so I'm putting maybe I should always have a start and an end. No, I don't think so. I want him to be null. So if we're in the middle of cheating, we can keep cheating. The start would still be the same start. Let's see, when I'm 0. This needs to be this current position, or yeah. Mabes. Okay, that's probably not right. I don't think it should take that long. Okay. If we're in the middle of cheating, I can continue cheating. Use the same start. And I think actually the new end should be this current position. U dot X U dot Y. Add 1 to the count. The cheat count, IJ. Yeah. Or I can stop cheating. That'll be U dot start. And that'll also be right here. Yeah, the end will be the same. And I just set the cheat limit. Set the count to the cheat limit. That actually, you might not want to do that. I might want n to be null. No. But if we've never cheated, we can start cheating right here, and then the end would be also right here. Count would be 1 IJ. Or I can continue not cheating. We have never start, so they're null. Still 0 IJ. And if we have we've stopped cheating altogether, then same start, same end, same count. Fuck. Alright, that's all I'm gonna do for now. Fuck this right now. Fuck. I'm gonna have to see what other people did. I've hit my 2-hour limit for myself. Thanks for watching. See ya.